Next problem. 4 varieties ABCD of a fertilizer are tested in RBD, randomized block design, with 4 replication. That is two-way classification, right? The plot yields in pound are as follows, right? Analyze the experimental yields. So first reframe the table. So fertilizer, there are 4 types. So A, B, C, D. Then yields, that is number of blocks. 4 times 4 blocks are there. So write for first write the details for A, 12, 14, 13, 15. Then for B, 10, 11, 12, 11. Then 16, 14, 15, 16. Then D, 20, 18, 19, 20. So all are equal, C1, C2, C3, C4. Next we are going to use the shifting technique. So shift the origin to 12. So the data is new data you will get, right? So subtract 12 from each number of the given data. So 12 minus 12, 14 minus 12, first row, 13 minus 12, 15 minus 12, right, for A. Similarly for B, 10 minus 12, 11 minus 12, 12 minus 12, 11 minus 12, etc., etc. Last D, 20 minus 12. So you will get new numbers 0, 2, 1, 3. So you have to use that number instead of the original numbers. So while shifting the origin, the number will reduce to small. So the calculation is very easy. That is why we are using shifting technique. Otherwise you can use directly. That is not a problem, right? So total number of data n is equal to 16. C, number of blocks 4. Number of treatments or fertilizers here, right? R is equal to 4. So null hypothesis, there is no significant difference between yield. There is no significant difference between fertilizers. Then alternate hypothesis, there is a significant difference between column and there is a significant difference between, that is row, that is fertilizers, right? So first ANOVA calculation table. So write the fertilizers A, B, C, D, yields 1, 2, 3, 4. Then write the revised data, right, after shifting the origin, right? Then first find the row total. First row 6, second row 4 total, third row total 13, fourth row total 29. Sum of the then similarly you have to find the column total also. First column total 14, second column total 11, third column total 11, fourth column total 60. Then you find the grand total, that is G is equal to adding all row total or column total, both should be same only, right? Same, that is G is equal to 52, same number, right? Then find Ri square by C1, first row R1 square by C1, that is equal to 9, R2 square by, right, C2, that is equal to 4 square by 4, that is equal to 4. Then 13 square by 4, 42.25. Then 29 square by 4, 210.25, right? Then add up all those things. Summation Ri square by Ci, that is equal to 265.50. Similarly find for this column Cj square by Rj. So first C1 square by R1, 14 square by 4, that is equal to 49. C2 square by R2, right, 11 square by 4, that is equal to 30.25. Then 11 square by 4, 30.25. Then 16 square by 4, 64. So add up all those things. Summation Cj square by Rj, 173.50. Next, sum of square rows. So squaring and adding all the numbers in the first row 14. Similarly for the second row 6, third row 45, fourth row 213. Similarly for the column, add the numbers before that, square and add the numbers in the first column. So 84 for the second column, 45, then 59, then 90. Sum up all those things, you will get sum of the squares, double summation xij square, that is equal to 278. Next find TSS correction factor, right? CF G square by n, that is equal to 52 square by 16, that is equal to 169. Next you have to find the total sum of square, that is equal to SS minus correction factor, so you will get 109. So take the numbers from the table, previous table. Row sum of squares, so summation Ri square by Ci minus correction factor, that is equal to 96.5. Then column sum of square, summation Cj square by Rj minus Cf from the table, right? 173.50 minus 169, 4.5. Error sum of square TSS minus CSS plus RSS, that is equal to 8. Then on our table, source of variation, column variation, treatment, that is row variation, then error variation. Sum of squares, CSS 4.5, RSS 96.5, ESS 8. Degrees of freedom, so V1 C minus 1 3, V2 R minus 1 3, and V3 R minus 1 into C minus 3, 3 into 3 9. Then mean sum of square column, that is equal to 1.5. Mean sum of square row, that is equal to 32.17. Then mean error sum of square, that is equal to 0.89. Then F ratio, first with respect to column, FC is equal to MCSS by MESS, that is equal to 1.69. Then row, FR, which is equal to MRSS by MESS, that is equal to 36.15. Next conclusion for yields, degrees of freedom V1 V3 3, 9, right? Tabulated value for degrees of freedom 3 9 at 5% level is 8.82, that is FT. Compare FC and FT. FC is less than FT, therefore null hypothesis 1 is accepted. Similarly for varieties or fertilizers, degrees of freedom V2 V3 3, 9. So tabulated value for 3, 9 degrees of freedom at 5% level, FT is equal to 8.82. Compare FR and FT. FR is less than FT, therefore null hypothesis 2 is accepted. Thanks.